All right, so this is not where I want to be because this is question 4. But this is test 4. So I want to start off with the free response question. So let's see what we got. All right. Part A, it says find and use VA and VB to explain why the particles will never collide when t is greater than 0. So what we need to do is first look up here and see we have the distance. So we've got our distance here for A, SA of t. So to get VA of t, we have to take the derivative. So the derivative of A is the velocity of A. So when we take our derivative, this one's kind of nice. We just have to do a couple power rules. So we're going to multiply by 5. So 5 times 3.2. So that's 15 plus 1 is 16. And then we subtract 1, so t to the 4th. We can do the power rule again. So 128 t. So 2 minus 1 would just be 1. And then minus 25, derivative of 25 is 0, so I don't need to write that. So we got SA of t. Now we need, or we have VA of t. Now we need VB of t. So that's the derivative here. So we take our derivative. So again, right here we have the power rule. So we can bring this 3 down. So negative 3t squared. Now this one we have to watch out. This is a multiplication. So it's 6t times e to the t. So again, we want to split those up alongside the variable. So we've got negative 6t. So first times the derivative of the second. So times e to the t. Plus the second, which is e to the t, times the derivative of the first. So derivative of negative 6t is negative 6. Derivative of negative 30 is, again, 0, just like 25, because derivative of a constant is just going to be 0. So I have my VA of t, I have my VB of t. Now I need to explain why they're not going to collide. So a lot of people picked up on this pretty well. VA of t, this thing is always going to be positive. Again, no matter what I put in for t, as long as it's greater than or equal to 0, well, I guess or 0, it's either going to give me 0 or a positive number. So that's pretty good. With VB of t, if we plug stuff in here, this is always negative. We're not going to get 0 because of this one, so this is going to be minus 6 right away. So even at 0, this would be 0, 0, and negative 6. So that one's always going to be negative. So a lot of people picked up on that and said, since A and B are traveling in different directions, they would not collide. And a lot of people put a period there, but that's not the end of the story. So we have one other piece that we do need to mention. I think only one person got this, so I did give people a little bit of extra credit on this one. But we need to also see where these things are starting, because if we have our track, if A is here and B is here, and A is going to become positive and B is going to become negative, those two things are definitely going to collide. So we need to say where their starting points are. Now, if it's the opposite, if B is over here and A is over here, then yeah, we're safe. These two things are never going to collide. So we do need to address the starting spots. So again, where do these things start at? Well, I mean, we could plug 0 in for them all, but that's kind of silly because we just know that's just going to be the two y-intercepts. So A is starting at negative 25 and B is starting at negative 30. So they would not collide because A starts to the right of B. And that's it. So that's how to do that one. So the points on this one, we would get 1 point for the green. Point number 2 comes from this purple. Point 3 comes from this part of the derivative. Point 4 is from the product rule here. 0.5 is from the power rules here, and 0.6 is just realizing that you were supposed to do a derivative. So that's how to get all 6 points on that part. So that's where all 6 came from. Most people generally did pretty good, so a lot of people got 4 or 5. If you got 4, it was usually 1, 2, 3, and 4. If you got 5, again, 1, 2, 3, 4, and 5. So not many people got this one down here. But that's part A. Part B says given a of t, the acceleration is 64 t to the third, and you could have figured that out. You could have actually done a second derivative. Plus 128, find a prime a of 2. Okay, well, that's not too crazy, because to do a prime a of 2, we're just doing one derivative here. So a prime a of t is, again, we just use the power rule, 3 times 64 times t squared. So that means that a prime a of 2 is 3 times 64 times 2 squared. And that's it. You didn't have to simplify it. If you did simplify it, that's going to become 2 squared is 4 times 3 is 12. So we'd have to do 12 and 64. So 2 times 64, or 2 times, 64 is 128. 1 times 64 is 640. So we would get 768. We need the correct units. So we'll go ahead and nab our units here. So for our units, remember, we just have to add one more onto the bottom. So up here, we're told that the distances are in centimeters. So this is going to be centimeters per. And so if we count, distance to velocity is 1 per second. Velocity to acceleration is 2. Acceleration to the derivative acceleration would be 3. So centimeters per second cubed. Now for a physical interpretation, we can write a sentence. We can just say rate of change of, and we can even keep it really generic, a of t at t equals 2. So we could be really generic with it. If we wanted to be more specific, we could say this is the jerk of a, capital A, at t equals 2. So we didn't need the physics interpretation. As long as we had the calculus interpretation that is the rate of change at t equals 2, that's all we would need to do for that. So again, the points on that one, you get 1 here for black. Point number 2 comes from the units in red. And then point number 3 is the physical interpretation. So that's our sentence here in purple. So that's it. That's all 9 points on that one. Again, we did pretty well with that. Here, a lot of people kind of missed the 3, so we just got to be really careful with our units. We did a really good job, though, usually with the derivative. So that was nice. All right. Down there. So for multiple choice, first one, since it's almost Chase's birthday, when we took the test on December 11th, we have 42 puns from Nick, Sam, and Spencer. So good job writing those puns. If we noticed one of the puns right here, maybe we saw that one, but that's okay. And we're going to write new ones. Currently, they're writing new ones at an average of 5 puns per night. So the derivative is increasing. So what pun amount could be the total on December 29th? So if they stayed the same, so let's say they did not have an increasing derivative. Let's say the derivative stayed the same. So that means that we would stay at 5 puns per night. Now we have to figure out how many nights there are. So I'm going to use the method that somebody did in class and say the 11th, 12th, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and then they're going to give the gift. So I've got 18. So it's going to take 18 nights. So if they were to stay the same, they would just write 5 every night. So that would be 90 new puns. We currently have 42. So that would mean if we stayed the same, we'd be at 132 puns. But we know that the derivative has to be increasing. So the answer has to be more than 132. So the only answer that is more than 132 is 190. So that's what we got for that one. So that's why that one's E. All right, number 2 tricked a lot of people. It says, what value could not be possible for our continuous function over -3 to 3? So this is the idea here is the intermediate value theorem. But the intermediate value theorem states which values must be possible, not which values must not be possible. So the idea here, which a lot of people thought about, was to think about these as points. So we got negative 3, 5, negative 2, 7 would be up here, negative 1, 10 is up here, 0, 7 would be about there, 1, 5 would be about there, 3, 1, 2, oh wait, we got 2, 2, 2, so 2, 2 is about there, 1, 2, 3, 4, 5, 6. 3, negative 6 is way down there. So our function looks like it might be a nice like downward parabola, but there's no way to say that it is a downward parabola. It just kind of looks that way from the dots, because our function could go like this. And then just be a parabola afterwards. So we could really have anything that we want because it is continuous. So everything's possible. So the answer to this one is E. Everything is possible. Now we must, so again, not going for must, going for possible. But we must go through 10, because we're already at 10. We must go through 0, because we have to go from 2 to negative 6. We must hit 6, because we have to go, I guess I'll take this one, go from 5 to 7. And we don't have to hit 12, negative 12, but we could. Negative 12 is possible. So for possible, this one's okay. For all these other ones in red, these are all musts. But since the question asked for possible and not must, we don't pick A, we pick E. So everything is possible. A doesn't have to happen, the others have to happen. So that's, I think, confused a couple people on number 2. All right, for 3, circular puddle is drying in the sun. Puddle has a radius of 5 inches, shrinking at a rate of 0.07 inches per minute. What rate is the area of the puddle shrinking? So again, we have our puddle, and it is shrinking. It has a radius of 5. And so that's what we got. So that is going to be our draw step. So if I list out my rates, our radius R is 5 inches. Our dRdt is our 0.07 inches per minute. I know that that's going to be the dRdt because that's matching up my units. We're going to find the rate the area is shrinking, so that's dAdt. So we're trying to figure that out. So we'll make our rate box. The equation, since we have a circular puddle, is going to be the area of a circle, which is a good old pi r squared. If we take our derivative, that means that dA dt, oops, lowercase d here, is equal to 2 pi r dr dt. Again, power rule, I'm just bringing the 2 out front. All right, when I want to substitute and solve, I can then plug everything in. So dA dt equals 2 pi 5 0 or 0.07. If I multiply these together, that's 10. 10 times 0.7 is 0.07 is just regular 0.7. So we get 0.7 pi. So that's what we got. If we follow our units, or if we think logically, area is in inches squared. Time in this case is in minutes, so inches squared per minute makes a lot of sense. All right, for number 4, we got our function y equals the square root of x with our point 49 comma 7, because the square root of 49 is 7, so that makes sense. Use this point local linearization to estimate the square root of 51. So since it tells us to do local linearization, we're just doing y minus y1 equals m times the quantity x minus x1. To estimate m, that's going to be like the derivative. So we need to find our derivative. And our x value we have is 49. So our derivative here, so derivative of square root x, remember that's just x to the 1/2. So it's another power rule. So with the power rule, we have 1/2 x to the negative 1/2, or 1 over 2 radical x. Oops, I'll write that over here. Now, if I want to plug in 49, that means I just plug in 49 right there. So that means that I'm going to be at about 1 over 14. So I'm going to use that for my value for m. So I've got y minus y1 equals 1 over 14. x minus x1. Now this is the point we know, so this is going to be our x1 and our y1. Y we don't know, because y is what we're trying to find out. Y is going to be the estimate. X is the point that we want to figure out. That's going to be square root of 51. So let's see what we got here. So we got, x is not the square root of 51. X is just regular 51. Sorry. So we got y, purple, minus y1. So y1 is 7 equals 1/14. X, because we're trying to find the square root of 51, so x is 51. We know the square root of 49, so x1 is 49. So we get y minus 7 equals 1/14 times 2. We got to add 7 to both sides. So y equals 2/14 plus 7, which is 7 plus, oops, not 7 over, well, 7 over 1 is true, but that is going to be 1/7 plus 7. So 1/7 plus 7 is going to be E. So just a normal local linearization one. So that's what we got for number 4. All right, for 5, the tree is set ablaze in a forest fire. Area on fire at time t is given by the function f, where f of t is measured in acres, t is measured in hours. Which of the following gives the rate at which the area on fire is changing at time t equals 13? So that at tells us we want to do a derivative. So if I look here, this is my derivative at 13, and that's it. So that's kind of it. That's kind of realizing that this situation is calling for a derivative. All right, for 6, we want to find the limit as x approaches 0 of our function here, sine of 3x over 6x. This one's pretty cool because you could have done it a lot of different ways. Since we're in the L'Hopital section, I'm just going to L'Hopital it. I'm going to check first, sine of 3, not 30, but 3 times 0 over 6 times 0 is 0 over 0. So that's indeterminate form. So that means I'm allowed to L'Hopital it. So the limit, I'm doing L'Hopital. So the limit as x approaches 0 of the derivative, sine of 3x, over the derivative of 6x. So this is going to be derivative of sine is cosine 3x. We have to use the chain rule, so we're going to go ahead and put the 3 out front. Derivative of 6x is just 6. If I plug in, this is cosine, not 3, cosine, it is 3, but 3 times 0 times 3 over 6. Cosine of 0 is just 1, so 1 times 3 over 6 is 1/2. So that's going to be C. Now, you didn't have to use L'Hopital. If you didn't want to use L'Hopital, you could have used one of our rules from Unit 1. You could have did the squeeze theorem rule. If we do that, that's where we would split this up into sine of 3x over 2 times 3x, and then realize that the limit as x approaches 0 of all of this part is just 1. So we get 1/2. So you could have done that too. So it's your choice. Kind of a fun one. So I did the L'Hopital way since we're in the L'Hopital section. But remember, L'Hopital is a limit technique. So you can use any of your old limit techniques if they work, or you can use the new one. And then we're at the end. So we're at question 7. So question 7 gave people a lot of difficulty with our sentient gelatinous rectangle. However, from the notes from 12.4, you can see we did the exact same problem as a review from a homework problem that was the exact same. People in class asked how the rectangle would even be increasing this way during class, so I made up a way for the rectangle to actually be increasing that way. So if the rectangle is a sentient gelatinous rectangle, it can actually increase that way. Done the same way as the homework problem, but I'll still go over it one more time. This is another dreads question. So I want to draw the gelatinous rectangle. Some people had some very cute gelatinous rectangles, so I appreciate the nice drawings that we had. But if we draw our gelatinous rectangle, we have our diagonal. So this is our diagonal. That's increasing at 1 foot per day. The sides of the creature are 3 feet and 4 feet. So we know that our diagonal is going to have to be 5. So in the rate box, we can kind of put those in. I'll just call these A, B, and C. I'll just go in order, just smallest to biggest. So A equals 3, B equals 4, C equals 5, dA dt. Let's see. So the larger side increases at a rate 3 times that of the smaller side. So we know dB dt is going to be 3 times dA dt, not 3a. So if we divide both sides by 3 here, we would know that dA dt, again, if I just divide by 3, is 1/3 dB dt. And then we also want dC dt. dC dt is increasing at a rate of 1 foot per day, because that's the diagonal. So dC dt is just going to be 1. So that's a kind of a busy rate box for a dreads question, but that's what we got. We have our equation. So in this case, I remembered this was a 3, 4, 5 right triangle. In case I forgot, I would have been using the Pythagorean theorem. And that seems like that's going to work out because our dB dt, oops, sorry, I forgot to do that. Find the rate the larger side. That's what we're trying to figure out is dB dt. So this involves a dB dt. So we take our derivative, 2a dA dt plus 2b dB dt equals 2c dC dt. Which that's already in blue. So we'll change that up. So that should be our derivative. And then we just substitute everything in. So 2 times a, so a is 3, dA dt, so that's 1/3 dB dt, plus 2 times b, b is 4, dB dt. Remember, we're trying to find dB dt, so we want to keep dB dt in the question, equals 2 times c times dC dt. All right, well, we got to keep going to figure out what dB dt is. So 3 times a third is going to cancel out. So that's 2 dB dt's plus 8 more dB dt's is equal to 10. But 2 dB dt's and 8 dB dt's is 10 dB dt's. And when we divide both sides by 10, we get 1. And so that's what we got. So that's how to do that one. So that's kind of everything that was on the test. Cool.